This properties of limits, we've kind of already talked about a little bit. It's how to split limits up. We've talked about that. We've looked at problems. I think we looked at a problem in one of our, let's see, was it this one? No, it's probably the other one. This one here, 1A, where we split up the two limits to solve it because it was easier that way. That's a property. That's the subtraction property because they're joined by subtraction. So this guy got a limit and this guy got a limit, right? And we split it up that way. That's one of the properties. We've actually used that property a couple times. Same thing with addition. If this was addition, you could do it that way, except the only difference is this would be addition. So we've used that property already. So that's one of the properties, okay? That's property 2, sum and difference, the one we just did. Scalar multiple. It means if you have, so if we have something with multiplication, so for example, the limit as x approaches c for 5 times x. I can move the 5 to the front. I can take the limit of 5x, or I can say, move the 5 to the front. Whatever I get for the limit, I'm going to multiply. That's an option too. We haven't been doing that one, but you could do it if you wanted to. Okay, you could do it. That's called the scalar multiple. It's a multiple. You just move it in front. Okay. Sum and difference we talked about. Product. Number 3, product. So when we have two things that we're multiplying times each other, two functions that we're multiplying times each other, you find the limit of the first one and the limit of the second one and multiply it. So you find the limit of f, whatever the limit of f is. Then you find the limit at g and multiply your answers together. Okay? As long as it's x approaching the same value. Okay? Same thing with quotient. Quotient's the same exact thing. Okay? The only difference is the bottom. So you have f on top, g on bottom, approaching the same value. So the limit for the bottom can't be 0. You can use this as long as the limit at the bottom can't be 0. Okay? Power, if you have a power, so if you have a function to a power, so for example, if we're doing the limit as x approaches some number for 5x squared, so the whole thing is squared, I can find the limit of 5x and then square my answer. That's what that says. You can find the limit for 5x, and then whatever answer you get, you can square it. Okay? You can square it. Or you can just find the limit of 5x squared, right? Because this guy right here is 25x squared. You could find the limit of that. It just gives you another kind of tool. These are all kind of giving you tools in your toolbox. Do you have to use them every time? No. Am I going to use a hammer every time? No. Am I going to use, this tool every time, saw every time? No, but it's just giving you tools to use. So if you run into something and you're like, oh, how do I do that? Well, one of these might help. And then the last one, composition of functions. So this is the one we're going to see today a few times. Composition of functions is when we plug in something, get an answer, and then plug it into something else. Kind of like you guys had on your summer assignment quiz. I think it was number 5 or 4 or 5, where you had to plug something into G, get an answer. Then plug that answer into F and get an answer. That thing. That's composition of functions. Okay, so what it says is, when you have something like this, when you have something like that, right? What you can do is say, okay, so first thing I'm going to do is I'm going to find the limit of G first. I'm going to find the limit at x approaches whatever for G. When I get an answer, I'm going to plug that in for f. So whatever answer I get, I'm going to plug it in there. Okay? And then that's your answer. So again, same thing we did on the summer assignment quiz. We start with the inside, find the limit of that guy. Find the limit of this guy here. What's that limit? Once you get an answer, you're going to plug it in for f. So it'll be f. So it'll be f of whatever that was, the answer. And that's your answer. Okay? All right. Okay, so let's do example number 1. Given that f already has a limit, they already told us the limit for f as it approaches a. Do I know what a is? Nope. But I know that as it approaches a, the limit is -3. I already know that. Okay? And the limit as g approaches, as x approaches g, or sorry, as x approaches a for g is 0. Already know the answer. Okay? And then there's another one, h. So they're all approaching a, right? They're all approaching a. 3 different functions. The limit as x approaches a for h is 8. So they gave me the answers already. But now I have to use that to figure out these guys. Okay? So the first one, a. So they want me to find the limit as x approaches a for f plus g. F plus g. So the limit for both of them being added together, combined. Okay? Or sorry, not g, h. So we're going to use the sum or difference one. The sum or difference, that matches the sum and difference. So what we're going to do is we're going to find the limit for one, find the limit for the other, and add them together. Okay? So I'm going to find the limit as x approaches a for f of x. And then I'm going to find the limit as x approaches a for h of x. I'm going to split them up just like that. Well, I don't even have to figure those out. They told me. They told me the answers, right? This is 3, -3, sorry. And this is 8. So your answer is 5. Okay. All right, now let's look at B. The limit as x approaches a for f of x squared. Okay. That looks like a power situation. A power situation looks kind of like number 5. So number 5 says find the limit of f and then use that power to use that power on the limit. So the first thing we're going to do is I'm going to find the limit as x approaches a for f of x. Again, they told me that answer. It's -3. And then they said take that answer and square it because it's squared, right? The power is 2. -9 or -3 times -3 is +9. So the limit is 9. How do I do letter C? Because there weren't any roots there, right? You didn't see any roots for the rules, right? There were no roots there. So what's a way I can change it so it doesn't have a root? Power, right? So what power is the third root? 1/3. So I'm going to change the way it looks. H of x. So it's going to kind of look like B with a power. like letter B, the one I just did. Okay. Well, I'm going to do exactly what I just did for letter B. I'm going to find the limit as x approaches a for h of x. Okay, they said that that's 8. So now what I'm going to do is I'm going to take 8 to the 1/3 power. What does 1/3 power mean again?
What are the numbers that equal to 8?
Third root, right? Yeah, third root. So yeah, what number, what single value do I multiply 3 times? That makes 8. 2. Done. Letter D, there's multiple ways. So letter D, there's multiple ways to get the answer. What's one way? The quotient rule, right? It's division. 1 over f of x. That's a way. That works. Okay, so let's leave. The quotient rule says what you're going to do is you're going to find the limit of the top number, find the limit of the bottom, the top function, find the limit of the bottom function, and then divide them. As long as the bottom doesn't give you an answer of 0. Okay, so this is what I'm going to do. I'm going to rewrite it. So I'm going to say the limit as x approaches a for 1 over the limit as x approaches a for f of x. So I'm dividing it up into 2 problems, and then I'm going to divide those. So what is the limit as x approaches a for 1? It's a constant, so it's just that number 1, right? And what is the limit as x approaches a for f of x? -3, which equals -1/3. What's another way to do that problem? I'm not going to do it again, but there is another way to do that problem using powers. How can I raise f of x up so it's not on the bottom anymore? What power? -1, right? I can say f of x to the -1 and move it up. So I can, another way, I'm not going to do it this way, but you could also say the limit as x approaches a for f of x to the -1 power. You can do that too. That works too. We already got the answer, so I'm not going to worry about it, but that works too. Okay. Okay, so let's look at, let's see here. Okay, so what I want you to do is I want you to do E, F, and G. We'll do H together. Do E, F, and G. So if the limit doesn't exist, explain why you can't do it. So we got -3/8, 0, and DNE. Letter G is DNE. Why is letter G DNE? 0 can't be on the bottom. And what else? That's one of the reasons why. But why else? Why does it become undefined? Because you have a number on top, right? Because if we got this guy here, if I had 0 over 0, that doesn't mean undefined. It does mean undefined, but it means we could still keep going, right? The reason it's DNE is because we got a number on top. Once we get a number, if we get a limit, if we do a limit problem, and we get a number over 0, that's DNE right there. DNE can't be done because we get 0 on bottom and a non-zero on top. Yeah. Non-zero over 0. Bless you. Non-zero over 0. 0 over 0 means there's work left to be done. We can factor, we can rationalize, we can do those things. Okay. Okay, letter E. So letter E, I like letter E because this is something that you see a lot in this class, and a lot of students, not a lot of students, but there are some students that freeze when they see this, and they just, I can't do it, right? As a calculus student, you can't be one of those. Now, am I saying you have to look at that and say, I know exactly what to do? No, you don't. But you have to be willing to think it through. This is not that bad. But once you start mixing things, things start looking different than they did yesterday, looking different than they did 2 minutes ago, that's when you got to kind of step up and say, oh, okay, well, what does this mean? Well, what are we trying to say here? Okay. So first of all, we have a fraction, right? It's a fraction. Okay, we got a quotient rule, right? On top, it's 2 times f of x. So 2 times whatever f of x is. Okay, I can do that, no problem. On bottom, all you're doing is subtracting, right? So the first thing I'm going to do is I'm going to kind of rewrite it so that I know what I'm doing. So the top is really, so what the top is saying, whoops, let me do this again. It's just 2 times whatever my limit is. So whatever the limit is for f of x, I'm just going to double it. So the first thing I got to do is figure out the limit of f of x. And multiply it times 2. Right? The bottom is just subtraction. So I'm going to get the limit of h, get the limit of f, subtract them. Right? This one's just mixing properties. That's all it's doing. It's mixing more than one property together. It's nothing we haven't done. It's just you're used to doing one property and be done. This one's mixing. That's the first thing. Okay. So limit it as f of x for f of x at a. -3. So the top is going to be 2 times -3. The bottom, h is 8 minus 0. Oh, sorry, -3. So minus -3. So we're really adding them. So the top I get -6, the bottom I get 11. Can't reduce it, can't divide it. You're done. What happens is, and I've seen this on FRQs, not so much on multiple choice. Multiple choice is pretty down the middle. Like there's really no surprises on multiple choice. You know what you're going to get. But on FRQ, sometimes they'll throw something out like this. And students see letters mixed together, F, G, F, combined, division, everything, and they kind of freeze. And they don't know what to do, or they refuse to think through it. I'm like, you got to think through it. That's the difference between you guys and the students, the other students, right? A lot of students have the ability to take this class, but some don't because they're like, you know what? I don't want to deal with stuff like that. I refuse to. But you guys are the ones who will deal with it. You can do it. Anything I give you in this class, you can handle. There's nothing in this class I will give you that you can't handle. Now, you might have to think it through, and you might make a few mistakes, but you can do it. Okay? Those are the students that do well in this class. Those are the ones that say, they look at this and they say, let's try it. Will they get the right answer every time? No, but they'll say, let's try it. Let's think this through, right? Not the students who say they see this and they're like, I can't do it. You know, they defeat themselves before they even start. That's not the type of student that does well. Okay? Okay, so here we go. Let's try example number 2. So let's go to the other side now. So they're doing the same exact thing. The only difference is they give you pictures now. Pictures instead of equations, they give you pictures, but pictures are just as good as words, as numbers. Okay, so let's take a look. Okay, so the graphs of f and g are given below. Use them to evaluate each limit. If it exists, if the limit does not exist, explain why. Okay? So f is the first graph, g is the second graph. Okay, so the limit, so for a, the limit as x approaches 2 for f plus g. Okay? So now we're looking at 2. So for a, I'm going to do each of them, add them together. So what is the limit as x approaches 2 for f? That's the first thing. So I got to figure out the limit as x approaches 2 for f. The limit as x approaches 2 for g. So for f, there's 2 right here. The limit, it looks like from the left side, I'm coming to positive 2. It looks like from the right side, they're meeting at positive 2. Y equals positive 2. So it looks like the limit is going to be 2. For g, it looks like they both meet, both from this side, takes a little jump there, right? And then here, they both meet at 0. The limit is 0 as x approaches 2. So you get 2. Look at b. Besides, it approaches 1 instead of 2. What's the difference for b? It's subtraction instead of addition. Good. What else? There's multiplication in front, right? So what am I going to do with 2 and 3? Put it in the front, find the limit, and then multiply. So I'm going to find the limit as x approaches 1 for f of x. Multiply it by 2. Going to find the limit as x approaches 1 for g of x. Multiply that answer by 3. Subtract them. Okay. So as x approaches 1 here. So what is the limit as x approaches 1 for f? Looks like it's 1, right? Yeah. Positive 1, y equals 1, right there. Okay. 3 times. What is the limit as g approaches 1? Yeah, it doesn't exist, right? It does not exist here. D and E, because 1 is here. This guy is approaching positive 2. This guy is approaching positive 1. They approach at, they don't meet. They don't meet at 1. If they don't meet, D and E. Limit as x approaches 1 for g of x does not exist. Can't multiply by a number that doesn't exist. So we can't do that problem. Okay. Last one, multiplication. As x approaches 0. So the limit as x approaches 0 for f times the limit as x approaches 0 for g. So let's see. The limit as x approaches 0 for f looks like it's 0. They meet at y when y is 0. At g. as x approaches 0, we look like we're right about there. Yep, it looks like they meet right about there. Kind of looks like 1.5. We'll just say 1.5. It doesn't really matter in the end because we're multiplying times 0, so 0. Okay. All right, so let's do letter D. Do letter D right now. If you haven't started already, try letter D. Okay, so letter D is the division property, quotient property. So we got to find the limit as x approaches -1 for f. So the limit as x approaches -1 for f looks like -1. And then the limit as x approaches -1 for g looks like 0, right? Yeah, 0. Does not exist. Does not exist because we have a non-zero over a 0, right? Non-zero over 0. Okay. Okay, letter E. Letter E is a combination of two things. Letter E is a combination of algebra and so equations and graphs. So in this class we look at graphs, we look at equations, and we look at tables. Those are the big three things. So this has two of them. So we're multiplying two things together. What are we multiplying together? X to the third times f of x. It's multiplication. So we have to find the limit of one and multiply it times the limit of the other. Okay, so I'm going to rewrite this. The limit as x approaches 2 for x to the third power times the limit as x approaches 2 for f of x. Okay, so the first one. How do I find the limit as x approaches 2 for x cubed? Plug it in, yeah. Plug it in. Just plug it in. 2 to the third power. 8. So 8 times the limit as x approaches 2 for f of x. That one I need to look at the graph. What did we say was 2? They both approach y equals 2. Then you get 60. Okay. Okay, so letter F. This one is a composition. We have G inside of F. And what else is different about this one besides the G inside of F? Yeah, we only from the left side, right? Only from the left side. So we're only looking at from the left side, from the negative side. Well, the rule said, let's do the inside. We're going to do the inside first. So this is what the rule said. The rule said f of the limit of the inside so let's find the limit as x approaches 1 from the left side for g. What do you get when you, for g, what is the limit as x approaches 1, just from the left?
2.
Yeah, it's looking like positive 2, right? Because the limit at 1 doesn't exist, because they don't meet, right? At 1, they don't meet. But just from the left, the limit is 2. So we're going to put 2 here. And then we got to find f of 2. What does that mean? F of 2.
Plug it in.
It means plug it in, right? Here's the thing. I don't have any equations to plug it into. So how can I do it using a graph?
You find the like it equals it.
So f is an, or 2 is an x value, right? They want the y value. So if x is 2, what is the y value here? 1, right? 1 right here. Look at the dot. I'm not looking for the limit. I'm looking for the answer, and the answer is at positive 1. This guy equals positive 1. Okay. So before we go to the last one, I'm going to give you one more problem. Try this one. We'll call this one G. Oops. Find the limit as x approaches 1 from the right for f of g of x. Okay, so we start on the inside. So we're going to say f of the limit as x approaches 1 over here for g of x. Just from the right side, right? Just from the right side. Positive 1. F of 1. F of 1 is positive 1. Okay. All right. Okay. So let's go to the last problem. Last problem, number 3. Given the following graph of f, so this graph is f, find the value of as x approaches 1 for this guy right here. Find the limit as x approaches 1 for this guy here. How do we do this? It's not as hard as you think. There's 2 ways to do it. What's that? Plug in 1 for x? No, kinda. Yeah, I know what you're saying is kinda. There's 2 ways to do this. Is there a property that I could use to help me with that green stuff? The addition property, right? Isn't it two things being added together? So can I find the limit for f of x at 1 plus the limit at 1 for 2? So can I do it this way? That's one way to do it. So let's see. The limit at 1 is -3. -3. And then the limit at 1 for 2 is just 2. Add those together and you get -1. That's one way to do it. I'm going to show you a different way. The other way involves translations or transformations, right? Transformations means graphs that move. How do graphs move, right? So think back from Math 3, especially with parabolas. We can move up, down, left, right? Parabolas can move around, or any graph can move around. What does this green tell us to do? X plus 2. I'll give you a hint. It's either going to be up, down, left, or right. What does that tell us to do? Up, down, left, or right. And it's probably the one you're not thinking. If you're not sure, it's probably the one you're not thinking. It's actually left. This one's telling us to move everything, all of this whole graph, every dot, move it left 2 units. That's what it's saying, right? I'll give you an example. That means up 2 units. That means down 2 units. And then the one we're looking at, and then this one. So up and down, if it's plus, you go up. If it's down, you go down. But up and down tells the truth. The one on the inside lies, right? So this plus 2 on the inside, when we say, oh, plus 2 means go right, actually go left. And right. Right? For a quadratic, in vertex form, it's written like this, H. We say H lies, K tells the truth. H lies because it says negative, but it's actually a positive. K tells the truth, it's actually positive. Right? So if it's -2 in the inside, it actually means it's moving to the right. If it's +2, it moved to the left. K tells the truth. K is always the guy that tells the truth. So the guy on the outside, so if there's numbers on the outside, like +2 and -2, those tell the truth. It moves up or down. But if it's on the inside, it lies. Okay? So how does that affect this problem? Well, what that means is I'm going to move every single one of these black dots here, or the whole graph, the whole curvy graph. I'm going to move it to the left. I'm going to move it to the left 2 units. So if I would move it to the left 2 units, that means this guy right here would be over here. That would be the new limit. That would be the new limit. That's where it would be. So if I moved everything left 2, because that's what that means. That's another way to do it. That way is easier for some people because it's all visual and it's no work. You just, okay, move it left to the 2. What would be there now? Well, that hole would be there now. So the limit would be -1. Or this way, 2 works. They both work. They both work. Okay? Stuff like that. They both work. So if it said this, so if it said the question said this instead, the limit as x approaches 1, f of x plus 4, that means I'm moving every dot up 4. Every dot up 4. So the limit was at 1, it was -3, right? That would go up 4 units. 1, 2, 3, 4. So it would be a +1. Or you could split it up and find the limit, because that's essentially what I did, right? I found the limit and then I added. Either way works. That's just what those, again, that's one of the things that you might see. You're like, uh-oh, it's not f of x anymore. It's got x plus 2. Well, what does it mean? You have a property, or what you can do is you can split it up property, or you can do transformations. Either one of them work. Okay. Okay, so this is what I think we're going to do. So this section isn't very long. I don't want to give you all day tomorrow just to do this assignment, because I don't think you're going to need it, because this assignment usually goes pretty fast. So what we're going to do is we're going to start continuity tomorrow. We'll start continuity tomorrow. I'm going to try to, so Wednesday and Thursday we'll do continuity. We'll do that second packet. And then Friday I'll give you time to do some catch-up work. So I'm not going to assign anything yet. We'll do it later in the week. Okay?